as long as we're talking about the continuity of functions, it's probably worth mentioning the intermediate value theorem for continuous functions. So in this theorem, it says if a function is continuous on a closed interval, then it takes on every value between its outputs at the two endpoints. So let's just draw a picture. It should be kind of geometrically obvious, even if it's kind of hard to prove. So let's see. We have a function that's continuous from a to b. So this function, if you plug in a, you're going to get out some value. Let's maybe call it f of a. So there's a point on the graph. And if you plug in b, you're going to get out a different value. That's going to be f of b. There's the corresponding point in the graph. And the idea is that if the function's continuous, then if you draw the graph, then it's got to have no breaks or jumps, which means if you pick any value between f of a and f of b, let's call it y naught, then there's going to be at least one place here, some point c, that we can plug in so that value y naught comes out of the function. So basically, if you look at the two endpoints of the function, then let's see, the values that come out at the endpoints, if you pick any value in between the endpoints, you know for sure on a continuous function that it goes through that value at least once. There might have been other choices for y naught, so different values, where actually the function goes through that one 3 times. So there are 3 points. The intermediate value theorem just guarantees you that you can find if y naught is a value between f of a and f of b, you can find an input between a and b so that f of c gives you that particular output. One place this is really handy is if you're searching for places where a function crosses the x-axis. Let's just look at this particular function. If you plug in 0, negative 1 comes out. If you plug in 1, you get 1 squared is 1 plus 1 is 2, 2 minus 1 is 1. If you plug in negative 1, you get 1 and negative 1, and another minus 1 would make negative 1. And if you plug in negative 2 squared is 4, plus negative 2 would be 2, 2 minus 1 is 1. So we know a couple things about this function then. If we're looking for zeros, we know that when you plug in 0, you get out negative 1, but when you plug in 1, you get out positive 1. And let's see, when you plug in negative 1, you get out, when you plug in negative 1, you get out positive 1. And when you plug in negative 2, you get out. Okay, good. So we know a couple things about this function. Since it's a polynomial, it's got to be continuous. That means there has to be a place between 0 and 1 where it crosses the x-axis. So we know there's got to be a 0 between 0 and 1. So there is a 0 between x equals 0 and x equals 1. We know that from the mean value theorem, since what comes out at 0 is negative, but what comes out at 1 is positive. It's a continuous function. It has to hit every value between negative 1 and 1, between 0 and 1. So there's got to be at least one place where it crosses the x-axis. We also know, because it's a continuous function, and it's below the x-axis at negative 1, but above the x-axis at negative 2, that somewhere between negative 1 and negative 2, it has to cross the x-axis. So we also know there is a 0 between x equals negative 1 and x equals negative 2. So this could help us hunt for the zeros. In fact, we could narrow it down. We could take maybe like negative 3/2 and plug it into our function. Let's see, what is f of negative 3/2? I just picked that as a point between negative 1 and negative 2. That's going to be 9/4, and then plus x, so x is negative 3/2, so we have 9/4 minus 3/2, and then we have minus 1. With a little bit of simplification here, this is 9/4 minus 6/4, right, would be 3/4, and 3/4 minus 1 is negative 1/4. So we just found at negative 3/2 the function is below the x-axis, and therefore we could narrow it down a little bit more. We know that there has to be a 0 between negative 3/4 and negative 2, because at negative 3/4 it's at negative 3, oh dear, negative 3/2. Okay, at negative 3/2, it's below the x-axis, but at negative 2, it's above the x-axis, and it's a continuous function, so it must cross somewhere in between. So we could actually hunt those zeros down in that way.